Hello everyone, my name is Jeffrey Actus and welcome to my presentation on how life cycle assessment, or as you know as LCA, supports sustainability decision making within the Canadian nuclear industry and all around the world. Today I will summarize what LCA is, why it matters in the energy sector, especially in nuclear context. I would like to share my findings and how we can use life cycle thinking and to guide more sustainable actions in Canadian energy future and globally. LCA help us understand the true environmental cost of nuclear energy and from uranium mining to decommissioning. It quantifies impacts like greenhouse gas emissions, resource depletion, and waste management across each phase. In the nuclear sector, this is crucial. While nuclear power offers low operational emissions, life cycle studies reveals upstream and downstream impacts like uranium extraction or spent fuel storage that must be managed responsibly for sure. For this presentation, I'm focusing on reactor design and material selection. LCA studies shows that a significant portion of nuclear energy environmental footprint comes from construction materials, especially concrete, steel, and high-density shielding. By integrating LCA early in the design stage, very crucial and important. And Canadian reactor projects can select lower carbon materials or optimize material use, significantly cutting life cycle emissions, especially for steel construction, for structural steel and piping systems and pressure vessels, as well as some other pressure components like valves and other pumps and any changeable maintenance items. A recent LCA of Canadian small modular reactor SMR designs like BWRX 300, NuScale, Smart, and some other examples identified construction materials as the dominant greenhouse gas sources. Sometimes over 60% of total life cycle emissions. It's a very huge number of percentage. Decision makers can respond by specifying low carbon concrete, sourcing recycled steel, and modularizing the fabrication to minimize transport and waste. And as you know, recent Westinghouse design mostly accommodate this criteria and mostly modularizing fabrication and shipping container units providing. And these steps align with Canadians' net zero 2050 goals while maintaining nuclear energy's reliability advantage. As we know, small modular reactors require large amount of concrete, one of the biggest aspects during the construction phase. About 25,000 cubic meters for every 100 megawatt electricity of capacity. Even so, the carbon emissions from this construction material amount to roughly 130,000 kilograms, roughly 130 tons of carbon dioxide, equivalent per megawatt built. To put that as perspective, if you consider a diesel generator which has 1 megawatt capacity, only produces the same amount of carbon dioxide in just about 20 days of operation. This simple comparison clearly shows how significant the impact of fossil fuel consumption is on global warming, especially when compared to the relatively small one-time emissions from building nuclear power systems like SMRs and other Westinghouse design. For Canada's nuclear industry to lead in sustainable innovation, it must embed to LCA into every decision stage, from seeding and fuel sourcing to displacement. Regulators could require LCA in environmental assessments, while utilize could use it to guide procurement and supply chain standards and other critical aspects. And Canadian specific LCA database for nuclear materials will make this analysis more accurate and transparent. Ultimately, LCA helps ensure that nuclear remains a truly sustainable energy solution, not just a low carbon one. From my own professional perspective, life cycle thinking reshapes how we approach design and planning. It pushes us to look beyond immediate efficiency and instead of considering long-term impacts, from resource sourcing to end-of-life disposal. Whether in engineering, policy, or environmental management, adapting to this mindset leads to smarter, more sustainable outcomes and solutions. To conclude, the life cycle assessment empowers Canadians' nuclear sector to make sustainable and measurable and actionable. By understanding the full picture from uranium to waste, with another naming cradle to grave, we can design systems that not only provide clean power but also minimize total environmental impact. Thank you so much for watching, and I hope this inspires you to see LCA life cycle assessment as a cornerstone of sustainable nuclear development and new future power generation systems.